Okay, we retain another integral. We've got the integral of 1 over x to the 2025 plus x to the 3037 dx. Okay, it seems like this one would be a good one for like the MIT 2025 integration and then you could reuse it again in 3037. So to get started, what I want to do is start with factoring. I want to factor out from this either x to the 2025 or x to the 3037. And for some reason, I always prefer to factor out the higher power. So when you do this, the second part, that's just going to be a 1. And then for this other part, we want the difference between 3037 and 2025. This is going to be x to the minus 1012. And then from here, what I want to do is let's just rewrite it, but let's take this part and bring it into the numerator. So when I do that, we're going to have this as x to the minus 3037. And then this stuff, x minus 1012 plus 1. And then from here, what I think I want to do is I want to do a u substitution. And a lot of times I like to include the 1 because it's like you get that for free. In this case, I think it might just make it more complicated. So I'm just going to take my u to be this. We'll set u equal to x to the minus 1012. Take a derivative on it, and then we're going to get, with power rule, minus 1012 x to the minus 1013 dx. And then before I actually substitute, I want to see if I can get this, I gotta see if I can clean this up a little bit because we've got x to the minus 3037 here. And I want to get it to look like this so that we can somehow have this be like a clean substitution. So I'm going to force this piece to happen just so that we have our du. So I'm going to write all that stuff down. And then here I need to put whatever's going to work so that when we multiply this times this, we get back our x to the minus 3037, so we're not changing it. We'll deal with the constant part first. If I have this as minus 1 over 1012, then this times this is just 1. And then for the exponent, we're going to want something with an x here. You'll notice if I make this x to the minus 2024 here, then when you multiply this times this, you get back the x to the minus 3037. So I think we're set to substitute. First, I'll take this out, this minus 1 over 1012 as a constant. Then this here, you'll notice this here is going to be the same thing. If you square u squared is going to be x to the minus 2024. So then we have u squared, and all this stuff we set up to be du over u plus 1. And this right here we can do, we've got the higher power here in the numerator, so I want to fix that. If I subtract a 1 here, now this is easily factorable, difference of 2 squares, but I don't want to change that, so I'll add a 1. And then what I can do is we can split this up into 2 integrals, just using this plus 1 on the second one. So let's see how this is going to look. We'll bring down this constant minus 1 over 1012. For the u squared minus 1, let's factor that right now. I'm going to factor that difference of 2 squares, u plus 1, u minus 1. Distribute this into this plus 1. So we'll have the second integral have the same constant in front, not 102, but 112. And then this is just du over u plus 1. Next, we can cancel u plus 1 with u plus 1 right here. Then we're just integrating u minus 1. So that's just power rule right there. This is an easy integral, so I think we're in good shape to finish this off. Let's just bring down this minus 1 over 1012. Integrate here, that's going to be u squared over 2 minus u. Then for the second one, constant in front, this here is just going to be natural log absolute value of u plus 1. Now over here, I'm going to drop the absolute value because I can see we've got an even power on the u and we're adding. So this piece here always needs to be positive. So we'll just get rid of that. And now I think we're ready to back substitute, but we're going to need, I'm going to distribute in this while we do it. So when we do the first term, this is going to become 2 times 1012 or 1 over 2024. See, it's important to get 2024 in the solution somehow. And then for u squared, it's going to be this value. I'm going to write it like in the denominator as 1 over x to the 2024. Then distributing in this to the second term, minus times minus is plus 1 over 1012. For the u, I'm going to write it in the denominator again as x to the 1012. Then for this last part, minus 1 over 1012, natural log u plus 1. Here, this is going to become 1 over x 1012 plus 1. But let's see if we can simplify just this part just a little bit. So first, let's get a common denominator in this. So if we have 1 over x to the 1012, for the plus 1, to write this 1, I can write it as x to the 1012 over x 1012. Then putting it together, that's going to be 1 plus x 1012 over x 1012. But this whole thing is inside the natural log, right? Inside the natural log here. So then with log properties, I can split this up and write it as natural log 1 plus x 1012 minus natural log x 1012. But we still have this constant in front, minus 1 over 1012. So we're going to, if we multiply it into this, what we're going to end up with is minus 1 over 1012 natural log of this thing. And then we multiply it in here, this becomes a plus 1 over 1012 natural log x 1012. But then with exponent properties here, I can bring the 1012 out front. That goes away, but then we have 1012 over 1012, so this just becomes a 1. So let's take what we found here and plug it back in here. So first we have this part minus 1 over 1012 natural log 1 plus x 1012. This right here just becomes a plus natural log x, add a plus c, and that's it. Wow, it takes up the whole board. It's a pretty long solution right there. Okay, there you have it. Interesting integral from the year 3037. Thanks everyone for watching. Have a good day.